All right, so here we have yet another rational function, and we're going to go through the same steps as before. We're going to notice right away, though, that we can factor out an x in the numerator, right? So that might help us a little bit. We're going to say, what's our domain? Well, the only thing we're going to worry about there is the denominator. So no divide by zero error, so we can't have x equal to 5. Of course, and there's no common factors top and bottom, so no holes, just a vertical asymptote at x equals 5. So this one, I'm going to leave my scale alone. We're going to put in that vertical asymptote right there. Okay, so we can say, well, do we have any x-intercepts? Because I skipped over that. Remember, that's where the numerator is going to equal 0. So we're going to have that when x equals 0. Right? And we're going to have that when x equals 6. So we can say, okay, great. We've got zeros right around those two locations. And then a y-intercept, right? What are we going to have? Well, it's 0, 0, right? We don't really have a separate y-intercept. Do we have a horizontal asymptote? We would say no, because the degree of the numerator is higher than the degree of the denominator, so none. But do we have a slant asymptote? Yes, we do, because 2 is 1 more than 1, right? So we're going to say, okay, great, we are going to do this division problem. We can do it with synthetic division. 1 minus 6, 0 placeholder for the constant. So 5, let's see, minus 1, doesn't matter. All right, so we've got the equation y equals x minus 1. So I can just going to kind of do this. If I go over 5, I'm going to go up 5. So we'll be here, over 5, up 2, 4, 5 here. So we're going to try to draw a nice dotted line through the right points. I don't know if that's going to happen. Oops. So far, I think I made it not slanted enough. All right, here we go. Okay, so close enough there. Right? And then we can say, okay, great. My zeros are going to tell me basically where my function is here, right? Because I'm here, so this has got to be doing kind of this thing. And I've got this one. So we know they can't be in this area because that's not where our zeros are. It can't be over here because it's got to be symmetric. So there we go. There's our graph. And we can even write some arrow notation here. We can say as x goes to infinity, f of x goes to x minus 1. Same story as x goes to negative infinity, f of x goes to x minus 1. We can also say, and write it over here. No, we'll just write it down here. As x approaches 5 from the positive side, f of x is going to negative infinity, right? Or going down. And one last one, right? As x approaches 5 from the negative side, that would be this side, y or f of x is going to positive infinity because we're going up. Okay. So some summary stuff. So this is just kind of everything we've learned in this section. We know vertical asymptotes occur at x values that are not in the domain of our rational function, nor the domain of the reduced function. We are going to have holes at any x values that are not in the domain, but are in the domain of the original function, but are in the domain of the reduced function. And then we're going to have horizontal asymptotes. One of 3 cases, right? We will have y equals 0, the x-axis. If the degree of the denominator is bigger than that of the numerator, we're going to have horizontal asymptote of y equals a over b. That's your leading coefficients. If the degree top and bottom is equal, and we will not have a horizontal asymptote if the numerator has a higher degree than the denominator. In that case, if the numerator is one higher degree than the denominator, we will have an oblique or slant asymptote. And remember, the graph will never cross a vertical asymptote, but it may cross a horizontal asymptote. And then this procedure for graphing, we've been doing this all along, right? Figure out the domain, find the zeros of the denominator, right? Find the zeros to determine the domain. If there's any common factors, reduce your function and make note because those are holes, right? Put in your vertical asymptotes. Sketch a horizontal or slant asymptote if there is one present. Find your x-intercepts by finding the zeros of the numerator, mark them. Find your y-intercept, mark it. And then if you need to, find a couple other function values and then connect the dots. Okay, so we've got 1 or 2 examples left and then we are done.